Hello and welcome to lesson 5.2, the natural logarithm. So just like other exponential functions have inverses, which are called logarithms, so does the function f of x equals e to the x. Thus, the inverse of f of x e to the x is called the natural logarithm because the function e to the x was called the natural exponential function, and is often given by the expression f of x equals ln x, which is pronounced, as you can hear I just said, ln. Now notice that it is improper to use log to the base e of x. Although it means the exact same thing, it just means that you're technically writing a little bit more, and not very many professors and or teachers prefer you to use that kind of format. Okay? So, just like I'm trying to say, if you have the function y equals 2 to the x, its inverse function is y equals log to the base 2 of x. Now remember that a logarithm is just the opposite of an exponential function, and therefore is used to solve exponential functions, and vice versa. Okay, so since f of x equals ln x is a logarithm, it follows the same properties as many logarithms. So in other words, you could take the arguments, ln of a and ln of b, and combine the two arguments into one, ln of ab. Same thing with ln a minus ln b, it equals ln a divided by b. One of the more interesting properties, ln of a to the exponent of p allows you to take the p and put it out in front, making p ln a. And one of the better changed base formulas, log to the base a of x, often referred to as ln of x over ln of a. Okay, so now we're going to solve some exponential and logarithmic functions using the inverses and simplify some statements. Okay, now please realize that what we're going to do is we're going to solve for the value of x using exact values in each of these cases. So the first thing to notice in this first one is we have e to the exponent 2x minus 5 equals 10. To get x by itself, it's in part of the exponent. So you need to get rid of that exponent by using some logarithmic properties. Well, in order to use a logarithmic property, you first have to apply a natural logarithm to both sides. It's kind of like just squaring both sides, or square rooting both sides, or dividing both sides by 5, something like that. Well, because natural logarithm and e are inverses of each other, you can either take the 2x minus 5 down from the exponent and make it a coefficient, or you can cancel the 2 and just realize it's going to equal 2x minus 5. Now we leave the ln 10 because the natural logarithm of a value of 10 is a constant itself, which is not a nice number, so we're just going to leave it as ln 10. Now to solve for x, we just add both sides by 5. So this is the natural logarithm of 10 plus 5. And then we divide both sides by 2. And we get this expression. Now, if you want, just so you don't get confused, you can write the 5 in front of the natural logarithm of 10 and divide by 2. A common error is you see in the 10 plus the 5. Just realize that's an error. Okay? Okay, so we're going to do something similar to part B. Now notice in this case, we're calculating the natural logarithm of x plus 2, which is going to equal 8. But we need to get the x by itself. So to get rid of the ln there, what we do is we apply e as the base on both sides, therefore making both the sides pieces of the exponents. Now again, e and ln are inverses of each other. So this gives us x plus 2 is remaining, which is still equal to e to the exponent of 8. Then to solve for x, we just subtract 2 from both sides. So e to the 8 minus 2. And e to the 8 actually turns out to be a really large number, so best to leave it as an exact value like this. Okay, let's try the next two. Well, for this next one, best to actually get rid of this 10 first. So to get rid of the 10, we divide both sides by 10. To get this. Now, although in advanced functions we told you guys to use logarithms to different bases here, I would actually suggest using a natural logarithm. So we're going to take a natural logarithm on both sides, like so. So this takes out of the question, should I be using log to the base 3 or log to the base 2? Now using our logarithmic properties again, we can take this x plus 1 that we have here as an exponent, bring it down in front as a multiplication to 1, 2. Now to get x plus 1 by itself, I'm going to divide by both sides by ln 2. And then to solve for x, I'll just subtract 1 from both sides. And there I get my value for x. Please notice that ln 3 over ln 2 cannot be simplified in any form because the arguments are different. Both arguments are 3 and 2. It's not the same natural logarithm. Okay, so what we're going to do is we're going to solve this one now. Okay, to solve this, I'm going to use a natural logarithm on both sides. The reason why I do this is because the exponent is 7x and it has that variable x. So now I can bring that 7x down, multiply by the natural logarithm of a half, and that's equal to the natural logarithm of 3/5. And here's where it gets a little fun. Some professors or teachers prefer you to break down natural logarithms that can be broken down a little easier into natural logarithms of just one whole number. So ln of 3/5 can be actually rewritten as ln 3 minus natural logarithm of 5. By the same idea, the natural logarithm of a half can be written as ln of 1 minus natural logarithm of 2. Now if you remember your properties of logarithms, a logarithm of the value 0 is just 1. Oh, sorry, logarithm of 1 is 0. So by the same idea, the natural logarithm of 1 is 0. So that cancels away. So we get this expression now. Now to solve for x, all I have to do is divide by -7 ln 2 on both sides. And there's my value for x. Another possible option for a value of x, sometimes they try to get rid of that negative in the denominator. You can reverse the numerator. And you can express it like this. And there's the value of x as an exact value. Okay. Last, we're going to simplify these kinds of problems. So here we have ln of e to the 3x. Again, notice the natural logarithm and e are right next to each other. Since they're right next to each other, you can cancel this. You can get just 3 times x. Here, in the next one, notice the e and the natural logarithm are not next to each other. So the trick is to get it so that they're next to each other. So how we can rewrite this is, because this is a 2 times the natural logarithm of x squared, you can rewrite this as ln of x plus 1 squared instead. Now the natural logarithm and e are next to each other. Because they're next to each other, they can cancel. So this would give us 3x plus 1 squared. And there we've simplified the problem. And thus concludes this lesson.